Hey everybody, it is Miss Williams and we are doing our second PowerPoint. This is Chapter 1, Section 1, Analyzing Categorical Data. So one thing in this chapter that we're going to have to know is pie charts and bar graphs. Columns of numbers take time to read. You can use a pie chart or a bar graph to display distribution of categorical variables more vividly. These two figures show both data they show the same data in different ways. What you have to know is that when you do a pie chart, your data has to add up to 100%, and then make sure that you always label your graphs and pie charts. So there are things that make things bad graphs, so be aware that you don't ever want to use pictures in a graph, and make sure, like I just said, that you always label your graph appropriately. So as you can see here, in this one, if you're just looking at it, it looks like people who bought Macintosh computers were extremely huge, while the people who bought Windows and none were very small. But really it's 300 to 100, which the small one is definitely not just 1/3 of the big picture graph. Another thing to be aware of is misleading or bad scales, because as you can see, the graph on the right is a bad scale because it doesn't begin at 0. Okay, it again looks like the people who bought PCs was really small compared to the other ones. But if you add the 0 and from 0 to 10 is put in there, it makes you see that PC and none are pretty comparable. Okay. So 2A tables and marginal distribution. A 2A table describes two categorical variables of an individual at one time. For example, we're going to be using this several times. Young adults by gender, and they were asked what do they think their chances of being rich by the time they're 30. So as you can see, this data is like a bunch of numbers, and you can see the numbers, but again, it's hard to compare. Okay, so what we're going to do is we're going to come up with some distributions. Marginal distribution is one of the categorical variables in a 2A table of counts. Is the distribution of values of that variable among all individuals described by the table. So here's your table again, and instead I'm going to put gender all together. Alright, so what percent of young adults thought they had almost no chance of being rich? Well, now I can see that's 4%, because I did the total of the genders, 96 and 98, and give me 194 over my overall total of my chart. Conditional distribution. A conditional distribution of a variable describes the value of that variable among individuals who have a specific value of another variable. So can you find the conditional distribution of opinions among females? So here's my chart again, and if I just wanted the conditional distribution of opinions among females, I'm basically going to cover up the male column of this chart, and now I'm just looking at the female totals. So 96 over this time 2367, because I don't care about the males at all. I just want the column of females. And I go through and do them all, each opinion for just the female column. Alright, now I'm just going to compare the two, males and females. This is going to give me an overall way to see where males and females differ. Okay, as you can see, almost no chance, they both had around 4%. Okay, and a 50-50 chance, they both had about 29.4 and 29.3%. Alright, so it helps me see where the two genders differ. Alright, again, all these numbers are great, but sometimes it's easier to see in some kind of graph. So there's a couple different graphs you can do to compare two sets of data. A side-by-side bar graph. So here's my stuff from the previous, all my percentages. So what I did is compare them side by side. Again, make sure your scale starts at 0, and then I went up to 40. Across the bottom, I labeled my graph, and then I also had to label which bar graph was males and which one was females. Okay, you can put dots inside the bar graphs, stripes, color one in, leave one unshaded, stuff like that. Okay, but make sure you always label your graph and give it a title. Another kind of graph that you could use is a segmented bar graph. There's that same set of data, and this time, segmented bar graph takes, because all my females that I questioned was 100%, so my percent goes up and down the left column, 100% goes all the way to the top, and then I just segment it off according to the percentage of almost no chance, some chance. And then again, make sure you give a key or label your graph. Okay. Last slide, association. What is association? We say there's an association between two variables if knowing the value of one variable helps predict the value of the other variable. If knowing the value of one does not help you predict, then there is no association. All right, we're going to do some problems with this and talk about this topic a little bit more. Make sure you bring your notes to class. See you later.